Good afternoon, dear students. Our today topic is about linear operators, and I have a question. What is the linear operator? What is the operator in general, by the way? And who wants to be the first? What do you remember about it? Or you don't? And I need to remind you. Okay. So it seems that you don't remember, yeah, but this topic is complicated as well. The whole linear algebra a little bit difficult. So yeah, uh, I will remind you. Let me share my screen. So actually, what is the operator? Operator is a mapping which puts which transforms one element to each other. So looks like this. So operator A, and we apply it to element X, and we get element Y. So it is so it's mapping. By the way, you know already such kind of mapping like just a function. So it transforms one number to each other to other number. But we also can transform vectors. We can transform matrices, functions. So different elements. Uh, so and now we will talk about linear operators. What is the linear operator? A linear operator is such operator in a linear space that that matches the following rules. So it's homogeneous. It means that we can. So if we apply this operator to the element multiplied by a scalar, by a real number, so we can move this number out of brackets. And other important property is additivity. If I apply so if this operator is applied to the sum of elements of linear space, it will be equal the sum of operators applied by this element separately. So looks like this. And we can often even unite these properties into one. So like this. Just a shorter form. Maybe you have some questions for now. Or you don't.
No questions.
Okay, so let's start solving tasks. Uh, yeah. So we have solutions here, but now let's do it in our own. So we have the following task. Given a linear operator which works by the next principle, by the next rule. So it adds element. So it adds the vector one. So to vector x, it adds some vector a. And we need to check if this operator is linear and how to solve. So who knows, who wants to answer, who has any ideas, how to check it? How to answer this question? Is the operator A is linear? Sophia?
We need to implement the conditions of the linear operators.
Yeah, not implement, but verify. Yeah. So we need to, we need to verify these conditions. You are right. And now let's do it. So if I do the next, so yeah, basically it will be equal. So alpha x plus alpha a. So it equals alpha x plus a vector. Forgot. And it will be equal. So the same. So we can move alpha out of brackets, but we need to verify also this condition. So let's do it. So applying operator A to the sum of x and y. So it equals x plus y plus L plus A. Oh, but it was a mistake here because yeah, it always it also not doesn't equal. Uh, so we just so it equals alpha x plus a. So this condition is not true as well, and I need to correct my materials as well. And yeah, we need to check both properties. So if we separately take, oh, not print screen, but I need to do this. So here is the result if we apply to operator to element x, and for y, almost the same. And if we add a x and a y, so what do we see? X plus y plus 2a. So is this operator is linear or not? What can we say about it? So as we can see, if we apply to the operator to the sum, and if we apply to elements separately and then add, we see that they are not equal. So what does it mean? If is the operator a linear or not?
Not linear.
Yeah, it's non-linear. So no, it's not. Any questions about this task? Okay, as I see now.
Can you explain first step here? How we get from A multiply on brackets alpha x and get alpha x plus alpha.
Okay, so we can mark, for example, y equal alpha x. And then, so what we have? Alpha y equals, okay, let's select another letter, let it be z because we y already use. So mark it as the following. And it will equal, so if we apply to z, so any element actually. And now we don't forget that z equals alpha x. So that's why it's not true. So this condition also doesn't is not matched, not met. So have I answered your question or not clear for now?
I'm not sure that it's clear.
You're not sure that it's clear. Okay.
Why we add vector A? I'm not sure.
Actually,
No, maybe not A, alpha. Yeah. So we
it's vector A.
yeah.
Actually, that's the rule by which this operator works. So you know, like functions, a function that so f, for example, f from x depending on x equals x plus a, for example, like it was at school. Analogically to this operator. So it takes the vector and vector x and adds to it vector a. It's just a rule on which operator works. So now do you understand why we add a?
Yeah, I think so.
Yeah, so I answered your question, right?
Yep.
Okay. Maybe more questions? Okay, no questions. So during the next task, it will be analogical to the task one, and I believe it will be easier for you because we will work with non-abstract vectors, but with more exact. Oh. And now we won't solve part B. A will be enough because B is analogical. So we is the same. We need to check if this operator is linear. So how it works? We have vector x that contains elements x1, x2, x3. And how the operator works? It transforms vector x to another vector, which contains following which coordinates are look in the following way: x1, then x1 minus x2 plus x3, and then 4x1 minus x2. We are doing the same. So checking if it's homogeneous. So by the way, alpha x will equal alpha x1, alpha x2 alpha x3. So actually nothing new for you already. So how it will it look like? Alpha x1 alpha x1 minus alpha x2 plus alpha x3, and for alpha x1 minus alpha x2. And you agree that we can move a out of brackets here. So let's do it. Because we have it here, here, and here. So x1 minus x2 plus x3. And then for x1 minus x2. And basically we can substitute it with ax. But let's write it here as equality as well. So we just move alpha outside of brackets. Now let's check it additivity. So we use it for a sum of x and y. And how it will it look? So here x1 plus y1, then yeah, this is 1. x1 plus x2. Oh, no. Plus y1, of course, minus x2 plus y2, plus x3 plus y3. For x1 plus y1 minus x2 plus y2. Now I will regroup these addends, and we will better see so separately x and separately y, and it will be easy to define if the operator is linear. So x1 minus x2 plus x3. So we will write it here. And y1 minus y2 plus y3. And here for x1 minus x2 plus for y1 minus y2. And we can write it as the sum of two vectors, because basically it's a vector. And what we see here that basically it is ax and that is a1 or ay. So ax plus ay. So is the operator a linear or not? What can you tell me about it? So what is the conclusion?
It's linear.
Linear?
Not linear.
Yeah,
Oh.
it's linear. You asked why it is linear, right? Or just confirmed?
I confirmed. I think Paolo.
Okay. Yeah, so homogeneity is fulfilled and the same for additivity. Any questions about this task? Okay, I guess that no questions.
I have
Ah.
no questions. It's a question not about this example. Yeah, it's in
Mhm.
general. In individual home task 7, how I remember, we have something like looks like this, but there we don't try to find is it linear or not. We perform the specific actions on the operators. It
Ah,
means
okay.
we didn't reach it. Sorry, we haven't reached it yet, or we have passed it. I'm not sure.
You definitely so you don't have so it's impossible that you had to do task that so we may not skipped it. So task 7.
Yeah, it looks
Uh,
like this, maybe, but
yeah,
we
but
don't.
please don't hurry.
It's because I remember our
Yeah,
our
but then
teacher said.
don't hurry. So
Okay.
we will do it today.
Okay.
Yeah, so
So okay.
don't worry.
Okay.
We will talk about it, of course. But now the first goal is to make sure that you understand how so what is the linear operator and how it works. And then we will do it. Seems that in the separate window, but it's inconvenient. Yeah. This panel from Zoom. Okay. So task B is so you will do it in your own. Then, but you already have solution here, but it will be better if you do it in your own. Okay, the next task, task 3. We have two bases, E1, E2, and E1 prime, E2 prime. We have the following linear operator, which is given as matrix. It is just a form of recording. How it is look like if we write it as a vector. So it will look like the next. Ax equals x1 minus x minus 2 x2 and x1 plus 3 x2. So it's just other form of recording. And it will be useful for us in this task to use the matrix form of the operator. Okay, so I have a question for you. How to solve this task? We need to find a matrix of operator A in basis in prime basis. So in initial basis we have the matrix, but we need to find it for basis E1 prime, E2 prime. How to solve? Any idea? Let's remember our previous lesson when we had to write vector in other bases. Which operations should we perform? Dmitro? Mhm.
I'm not sure, but we can take, for example, the first row of our matrix A as the first basis, so E1, and then apply the rule, like the how is this called?
What are you going to do with these vectors? I don't clearly understand.
I don't know either.
So how are you going to use them? You don't know what we were doing on the next lesson, on the previous lesson, when we moved to other bases.
Well, we just take the original basis vector and apply the this E1 strich vector.
Prime, yeah. So maybe any specific matrices were used for that.
I don't remember.
Okay, Bogdan, okay, you want to help us, as I see.
Yeah, if I'm not mistaken, we must make a transition matrix from one
Mhm.
basis to another.
Yeah,
And yeah,
and do you remember the formula for linear operator? How to build it? How to move from one basis to another?
we take the previous one and multiply it. No, for the inverse matrix of transition matrix
Mhm.
multiplied by the A operator A. Yeah.
Is that's all or not?
Um, and maybe multiplied with transition matrix again.
E- okay, from the left it is multiplied by inverse transition matrix, and now from the right by initial transition matrix. So Dmitro, now, so any questions about it? Maybe how to build this matrix? So do you remember it? How do we use the transition matrix?
No.
Oh, okay, and how to build it as well? Okay, and who wants to answer how to build a transition matrix? Oh, okay. Yeah, Dmitro, just now please assist me with building the transition matrix. I will uh, tell you what to do. So I will tell how it is built, and you will tell me coefficients. So transition matrix is built with using these vectors, new vectors. And how do we build it? We take each vector and write it as a column of the matrix. So which coefficient will be here?
1,
Here,
also 1,
y, 1,
or -1.
-1, and yeah, because,
Oh, I see. Okay.
yeah,
Okay, yeah.
and
And
here,
then 3 and -4.
yeah. So this is the transition matrix. So now do you understand how it works?
Yes, yes.
Okay. And now let's find the inverse matrix. First of all, find in cofactors. So T11 equals -4. T12 equals 1. T21 equals -3. And T22 equals 1.
Why is it -3?
-3. Do you remember how to calculate cofactor?
Oh, well, I think yes.
So it is calculated in
Oh,
the
yeah,
next
we
way.
need to take,
So
yes, we need to take
yeah,
-1.
don't forget,
So, right.
don't lose this multiplier because it will affect all your task. So we multiply minor by -1 in power of I plus j,
Okay.
and we have power of 3, so power 3, so -1. So yeah, be attentive, don't lose signs because it's painful. So -4 plus 3. So determinant of t is -1. No fractions. I like such matrices. Okay, so t equals, don't forget that we are transposing, so -4. Ah, yeah, and we don't lose -1 before the matrix, by the way. So -4, 1, -3, 1. Yeah, don't forget that it's transposed. So here is our matrix. But let's also verify. Yeah, so it's correct. So 1, 3 minus 1. Stop. Mhm. Yeah, everything is okay. Yeah. And now let's multiply. Let's find the matrix A. I can just use this formula. Sorry. Just a moment. Okay, now let's continue. So first of all, we take matrix T, T inverted. And then matrix A, 1, 1, and -2, 3, multiplied by matrix T initial. So first of all, let's multiply these matrices. So 4 by 1 plus 3 by 1. Now let's write in details. Then 4 by -2 plus 3 by 3. Then -1 by 1, -1 by 1, so just -2. And then 2 minus 3. 7 minus 2 minus 8 plus 9, so 1 and minus 1. And again, multiplying by matrix T. So 7 minus 1, then 7 by 3 minus 4, then minus 2 plus 1, and then minus 2 by 3 plus 4. 6. 21 minus 4, 17. Minus 1 and minus 2. So this is the answer, the final result. Of course, let's verify that everything is okay. So 6, 17 minus 1 minus 2. And everything is correct. Any questions about this task? No questions, right?
No questions.
Okay, let's move next. So let's see if solve now or go or have a break. What we have the next? Yeah, so spoilers that we saw before, and now we will find the product of operators. And I have a question: how to calculate product of the operator? What does it mean basically? Is it the similar to usual products that we already had before, or something other, something new for you? Okay, so you don't remember how to calculate product of operators, of linear operators.
No.
Basically nothing. I don't. I won't say that it's complicated. So it just means that you apply operator. So okay, I will write. So the product of operator A and B by X. So it means that firstly we apply operator B to X, and then we apply operator operator A. So it is the product. So A ABX doesn't equal the next. It doesn't equal. So even I will write it in red. Doesn't equal. So it's not possible. So maybe possible, but for some specific cases. But generally speaking, no. So it doesn't mean a product of operators. So operators applied to elements. So it doesn't equal AX multiplied by BX. And the power of operator means that we apply it twice. So some time. So okay, maybe in 1 month or maybe 2 months, we will calculate derivative. So we'll differentiate functions, and actually differentiation means using differentiation operator. So the second derivative is the power 2 of differentiation operator. But of course, you will know more about it a little bit later. So, any questions maybe about these formulas? Okay, no questions. So let's start solving. Uh, any ideas maybe how to solve? What can you suggest? So no ideas. Maybe should we rewrite this operator's transform for easier to solve it in a comfortable way or not?
I think that first we need to calculate the operator B on X, and after that operator A on the result of operator B.
There is a easier way to solve this task. Of course, we can do it, but it's complicated a little bit. So we can make a lot of mistakes if we do it. So we can substitute then x2 plus x3 as y1, this is as y2, this as y3, and apply x, then expand, of course, but we can do a lot of mistakes. Maybe should we rewrite these operators? Okay, we will rewrite it to matrix forms. So how to do it? Basically, we take each element of the vector and set it and write it as a row of the matrix, a linear operator matrix. Don't confuse it uh, with transition matrix, because for transition matrix we use we write vectors of other bases as columns, but these elements of vector we write as rows. So we have x1, x2, but no x3. So here is 0. So we write coefficients before x1, x2, and x3. So 0, 1, 1. And here 1, 0, 1. And matrix B, uh, 0, 1, 1. Then 1, 0, 1, 1, 1, 0. So here is the matrix B. So how to find the product of these linear operators if we know matrices?
Just multiply matrices by
Yeah,
each other.
it will be product of these matrices. So AB. And let's multiply them. I know you don't like multiplying big matrices, me too, but we have no ways to solve this task except multiplying matrices. So let's do it. So 1 by 0, so 0, 1, 0. So just 1 here. Then 1 by 1, 1 by 0, 0 by 1. So 1 here as well. Then 1 plus 1 plus 0, 2. 0 plus 1 plus 1, 2. 0 plus 0 plus 1. 0 plus 1 plus 0, 1. And 1 plus 0 plus... Oh, no, I multiply. So I need to multiply this row by this column. 1. So 0 plus 0 plus 1. 1. 1 plus 0 plus 1, 2. And 1 plus 0 plus 0, 1. So here is the matrix of product of this linear operator. Now let's verify. So 1, 1, 2, 2, 1, 1, 1, 2, 1. Yeah, so correct. And now we need to write it in explicit form. Let's write it as C. So let's mark it C, and we have the next operator C. So explicit form means to write it as a vector. And what we do, we just take these rows and write as the coordinates. So Cx has the next explicit form. x1 plus x2 plus 2x3. 2x1 plus x2 plus x3. And then x1 plus 2x2 plus x1. Oh, plus x3, of course. Okay, so here is the operator C, product of operators A and B in matrix form, and here it is in explicit form. Do you have any questions about this task?
No,
No? Dmitro, no questions?
no, I don't have any questions. No.
Okay. So now let's have a break. Oh, Bogdan, a question, right?
Yeah, I had the question about explicit form, right?
Yeah, explicit
Is it
form, явна форма.
is that the vector form that
Yeah,
we
it's
did?
the vector
Okay.
form.
Okay.
You have the definition like vector form, right? So yeah, we can use different terms. Okay. So now let's have a break for 5 minutes, and then we will continue working with the linear operators. Okay, let's continue. Okay. So we found the product of operators. Then we have identical task. Task C. Oh, no, task 5. So we find two products of operators and then subtract them. So find in operator C. So just more actions here. 6, 7. Yeah. So let's go with the 6. Interesting task. So let's go with it. So we have operator A in basis E1, E2. So given with this matrix. And operator B in basis E1 prime, E2 prime. Also given with the matrix form. And we have to find the matrix of operator A plus B in basis E1 prime, E2 prime. So for now, let's solve part A. B, if we have time for that. So the first question, how to solve? Who can answer? No ideas, yeah? But we already we're doing the similar task. Sophia?
I guess using the formula was A prime equals inverse matrix T and A T, like
So,
this.
okay, so do we need so we need to find A prime, yeah. And what about B? Do we have to do anything with this matrix or not?
We don't have to do anything because it's already in our E prime basis.
Correct. Yeah, correct, because it is in the prime basis. So let's do it for A only. So first of all, we are building a matrix T. Transition matrix, and it has the following form. So 1 minus 1. And the first column, and the second 1, 1. Finding cofactors. Oh, no, not 1, 3, but 2, 2. It equals 1. Okay, now let's calculate determinant of matrix T. So 1 plus 1, just 2.
Sorry, shouldn't be the T of 1, 2 equal to minus 1?
Of 1, 2?
Yes.
So minor is -1, but the cofactor,
Oh, -1. So yeah.
yeah, don't forget it. Just to remind you, so don't lose this important multiplier, which affects the whole task, the final solution. And when you do your individual tasks as well, don't forget to verify it, that you don't lose -1, and for testing as well, so for all works. So t minus 1 equals 1 second multiplied by 1, 1, -1, 1. Okay, so now let's find matrix A prime. Okay. Three, 1, 5, 2. Okay, 3, 3 minus 5. Let's write in details as well. Then 1 minus 1, so just 0. 3 plus 5. And 1 plus 1. Okay, let's write 2. Yes, Sophia, you have a question?
No, I guess you wrote the matrix A incorrectly.
Yeah, thanks for your comment. We'll fix it, of course. Okay, let's write it. Thanks for correcting. That it means that you are following. So 3, 1, 5, 2. Yeah. Okay. So but anyway, 3 minus 5 we have here. Nothing changes for this cell, and for this 1 minus 2, so it's -1. And then 3 plus 5. Okay. Then 1 plus 2, 3. Okay. And here let's yes, let's simplify first of all, and then we will move next. So minus 2 minus 2 plus 1 minus 2 minus 1 8 minus 3 and then 8 plus 3. So minus 1, 5 minus 3, 11. And now multiply by 1 second, so minus 0 0.5, 2.5. No, comma will be correct, but never mind. And it is not the final answer, of course. So the final task, what we need to do is to add these operators. So don't forget about it. Yeah, I know that sometimes students think that that's all, but yeah, I need to do one simple calculation. So a plus b, a prime plus b. 1, 2 minus 2, 3. Yeah, I say one thing and do other thing. Yeah, so let's add 0 0.5, 0 0.5, 0 0.5 as well, and 8.5. And this is the answer, the final answer. Any questions about this task? Or no questions?
No questions.
Okay, and I have a question for you. So if we need so for section B, we need to find the product of AB in basis E1, E2, not prime. So matrix A, okay, we have it. And how to find matrix operator B in initial basis? Do we have everything for it, or we need to find one more transition matrix?
Well, we need to find matrix B in basis E1 and D2 instead of E prime and E.
So we need to find the matrix B in
Yeah.
basis E1, E2, because we know it already in a prime basis. And do we need other transition matrix T, or this matrix is enough for us? Yeah, Dmitro?
We probably do need another one.
New matrix, yeah, to find the new, or just to use existing?
No, I think we need a new matrix because it's another, or maybe
Actually
I'm
not.
sure. No? Okay.
We don't need it. So we have matrix T and inverse matrix T. But if we, so for finding matrix A prime, we need to do, so we need to multiply it by matrix inverse matrix T from the left and initial from the right. But for B, okay,
We need
let's
to
mark it as prime now. And to find the B, we need to multiply B by B prime by T matrix, initial T matrix from the left and inverse from the right. So to move from prime basis to initial normal basis, we need to swap transition matrices. So we just we need to swap these matrices, and that's all. So it's enough to have only one transition matrix. We don't need to find more.
Okay.
Any questions about it? Okay, no questions. So now let's move next. Okay, so B will be your homework, and basically you have already a solution for it, but first of all, do it in your own, of course. It will be useful for you. Task 7, identical tasks that we were doing before. So we have two matrices. We don't need even to write explicit from to matrix, and you just need to do simple actions. Add matrices and multiply for different sides. Then task 8 is interesting. And what about task 9? Task 9 is identical. So task 8, we have linear operator in R3, so in a 3D space, and we need to find its kernel, image, and rank, defect, and basis for image and kernel. And I have a question. What is the kernel operator? What is the image? What does it mean? So what is it? Do you remember or not? Sophia?
Kernel, it is the set of vectors for which operator A that acts on the vector x equals 0.
Yeah, it's correct. So that is the operator. So it is the set for which we have zero vector, because we are now in R3 space, so not just R. So zero element. Let's call it like that. Correct. Okay, and who can answer what is the image? So who can answer? Maybe anybody else? So who can help your so who can help your colleague? Okay, nobody wants or nobody remembers, but now let's remember what are we talking about? Yeah, so what is the image?
I can answer.
Yeah, Sophia, answer. If no volunteers, of course.
So this is a set of vectors, like a vector y equals an operator A that acts on the vector x, like this.
Yeah, basically, so it's just like for function that So we had definition space, but also definition set, but also the set of with values. Область значень. So if you remember, so image A, so it all X basically. It's okay. I won't write it, but it will be enough. So we need to find everything for this operator. So first of all, let's find the kernel. First of all, we need to rewrite our operator in matrix form. So 2 minus 1 minus 1, then 1 minus 2, 1. 1, 1 minus 2. Okay, and now how to find the kernel? So, with knowing the definition of the kernel, okay, I will remind you. So, we just need to solve this equation system. So a x equals 0, 0 element, and that's it. And maybe it will be correct capital theta, but nevertheless. Okay, so let's use our favorite Gaussian method. First of all, I will swap rows for more convenient calculation, elimination. And now we will eliminate the first column. So now what we have here, so minus 2, so we have minus 3, minus 1 plus 4, 3, then so 0, and minus 2 minus 1 is minus 3 as well, and minus, so 1, stop, just a moment, so 0 and so minus 3, and here yeah, so 3, correct, multiplied by minus 1. So I like losing signs as well, but of course I like finding them. So here is the system. By the way, what is the rank of the linear operator and its defect? Sophia?
Defect, this is the dimensionality of kernel, and ring is the dimensionality of image.
Okay, and rank, yeah, it's dimensional of image, but basically it is equal the rank of matrix of the linear operator. So yeah, we can. So now we know the rank of its matrix, and what is the rank of A?
It is 2.
Yeah, it's 2 equals 2. Okay, and the defect. So the rank of the defect. Yeah, it equals basically. Uh, So n minus rank A. And so it equals 3 minus 2, 1. So it is the defect. Yeah, and it is dimension of kernel, and this is dimension of image. Okay, now let's find the kernel. Let's find the matrix. Let's find the solution. Find in a shortened system. Oh, no. Minus 2 x1, oh, x3, I'm sorry. And x2 minus x3 equals 0. So, this is basis variable x1 and x2, x3 are free variables. So, x2 equals x3, so they're equal. And x1 equals minus x2 plus 2x3, and it equals x2 or x3. Okay, so now let's find the general solution. So we mark x3 as C, x2 as well, actually, because they're equal. C is any real number, and the general solution is C, C, and C. And this general solution equals kernel of operator A. And what about the basis? We will find it. So the basis of the kernel is any vector that belongs this set. So just one. Let's take 1, 1, and 1. Fundamental solution system. So actually, that's all that we need here. Okay, maybe any questions? About this task? About the lesson, previous lesson, your individual tasks, homework? It seems that you have no questions. Okay, I will see if we have. I have a mistake here, so don't look here. First of all, I will correct it. Okay. Task 9 is identical, and other tasks as well. So nothing new to solve in details. Maybe so no questions, right? As I see.
No question.
Okay, so our lesson is finishing. Have a nice day. Stay safe. Thank you for your attention. Recording will be available on YouTube soon.
Goodbye.
Goodbye.
Thank you. Bye.
Goodbye. Have a
Thank you.
nice day.
Goodbye.
Thank you for the lesson. Take care.
Thanks.
Goodbye.